All right. So these are two questions that kind of came from last week's live stream that I didn't do because I was sick and I was tired and I just couldn't do it. But I'm going to try to satisfy them as well because I have some kind of questions. They wanted to kind of understand like how do we create Pascal's triangle and then how would we expand this. So I'm not going to simplify it, but I will expand it at least for them. So first of all, whenever we have the expansion, we need to understand that, first of all, we couldn't multiply them out. And I have students that have done this over and over. Like you can multiply 2x minus 1 by itself 5 times. But really, to multiply that, you can already see how much work this was. Like just imagine like multiplying that out. It's going to be a lot of multiplying. And I had students that just did it on their quiz and their test. Or like, you know what, I'm just going to try it. And some of them got it right, but most of them got it wrong. So my advice to them was saying, all right, let's go through understanding the binomial expansion as well as the Pascal's triangle. So let's just create Pascal's triangle. And Pascal's triangle a lot of times starts, or to understand Pascal's triangle, it starts with this kind of triangle of ones. Now again, Pascal's triangle basically gives you these coefficients without like the 2 here. If we just had, for instance, if this was like x minus y to the 5th, Pascal's triangle is going to give you the coefficients of each and every term of the binomial expansion. Now, obviously, once we have any numbers as coefficients there, that's going to be used as a scalar. So this is really going to be any term raised to the 0 power, any binomial raised to the 1st power, it's just 1 and 1. And then any term raised to the 3rd power is going to be 1, 2, 1. So one thing that you can, let me see. Yeah. One thing that you can always remember is, I'm sorry, that's not to the 3rd power. That's to the 2nd power. That's to the 1st power. That's to the 2nd power. That always, the second term always kind of tells you what that power would be as it would be expanded. Because I think when you're trying to get to like the 5th power, you're like, well, what is the row in the Pascal's triangle? So again, if you were to expand Pascal's triangle to, or a binomial to the 3rd power, you would have these scalar coefficients of 1, 3, and 1, 3, 3, and 1. Now, how do we continue building Pascal's triangle? Well, again, if you kind of notice the pattern here, the 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. And then you can kind of continue that pattern all the way down. And again, this is going to be a binomial to the 4th power. And for this question, we wanted to know what is the scalars for a binomial to the 5th power, which again is going to be this row. But you can continue following the pattern of adding 2 terms to get to the next row. All right. Now, the main important thing is really understanding these binomial expansion. This is something that I spent a whole lesson on, so I don't have time to go ahead and do that. But what I will say is the first term is always going to be to the power of your binomial expansion. The second term is going to be starting at 0. And then basically what we do is we take the first term going down in descending order and the second term going into ascending order. So it's going to be plus 2x to the 4th, negative 1 to the 1st, plus 2x cubed times negative 1 squared, plus 2x squared times negative 1 cubed, plus 2x to the 1st times negative 1 to the 4th, plus 2x to the 0 times negative 1 to the 5th. Now, it's important when you have this negative 1, this second term, because it's really 2x plus a negative 1 to the 5th power. But it's important that that's going to give you actually an alternative term. It's going to go positive, negative, okay? Now, the other thing that's important here is that we're not done. This is just the binomial expansion. Remember, these terms give us our coefficients. So that's going to be 1. That's going to be multiplied by 5. This term's going to be multiplied by 10. This term's going to be multiplied by 10. This term's going to be multiplied by 5. and this term's going to be multiplied by 1. So again, that's why those terms, each and every one of those terms is going to be multiplied by Pascal's triangle. And that's how we use that binomial theorem as well as Pascal's triangle